A few days ago I made this key slot in this spacer ring for the lathe. To make these key slots, of course, I use my slotting bar, but there is a little bit of a problem. I can't use this vise because there's too much stick out here. So I have to put this vise really on the edge. I don't think it's a good idea to do it this way. The second problem is that the clapper box and this nut here will touch the backside of the vise, so that doesn't work. To make this kind of small parts I have to use this flimsy little drill press vise, and I can't put my part like this in this vise because there's not enough wide. So I have to cut upside down the slot on the top side. Second problem is, of course, first I have to put my part on the bar, a bit like this, and then I bring the table up and then I clamp the vise. I think that is absolutely ridiculous to work this way, having a beautiful little machine and then a flimsy setup like this. Of course, when the part is sticking out too much, especially with these smaller parts, there's a lack of rigidity. Let's make something better. I have here a beautiful piece of L-shaped iron thing, and I think this could be very useful. Of course, I'm gonna cut a piece off, make it the same width as the table, and to make it more rigid, maybe cut out two pieces out of this so I can bolt it here in these existing holes to hold it together. That could work. Let's do this. I didn't even start yet and already the first problem. That doesn't fit. Yeah, not sure. Next problem is now, of course, I need to clean up this face that goes on the table, and this face on the inside needs to be square with the face on the outside of the table. Maybe if I install here my angle plate and I can install my part like this. I have just enough clearance here. That might work. An easy way to check if a rough and rusty part like this is aligned with the ram, we're gonna use this cheapy, these are feeler gauges. I cut the point off and I put whatever thickness, it's not important. I'm gonna feel the drag right here. That is good. I'm gonna move the part the other way. Feel again. And here we see that it's completely loose. So this corner is higher than this corner. Let's check over here. Completely loose. Touching. All right. So now I know that this corner is the highest point. I don't know with this system yet how much difference there is, but for a rough surface like this, it's not important. In a previous video I talked a bit about maybe using carbide in the shaper. Now for this surface it could be a good idea. And I talked about this piece of leather or rubber that will protect the cutting tool on the backstroke. And in the comments some of you pointed out it should be good to have an automatic clapper box lift system. Now when I bought this machine it came with an automatic tool lift system. This bar was mounted right here and this piece was here. Now I can't put it in place anymore because I installed these oilers, so they're in the way for this thing. And then this side is fixed, and with the movement of the ram, if it wants to move, it's a bit hard to move. You have here this pin and of course a little bit of movement here. So on the backstroke this block will be that way, and on the that way, and on the cutting stroke the block will be pushed to the back. And now cutting stroke. Mounted on this sliding bar you had this bizarre looking thing. This used to be here below, fixed on the clapper box, not the clapper. Only this little thingy was fixed to the clapper, and this used to pull the clapper out on the backstroke. And the movement came from this thing here that was fixed on this bar, and then you have this little handle here. And to make it work there was some curly thing here, and then you had always these two long balls that held this piece up here, always in the way, and the thing never worked because this is cable like bicycle brakes, and on cables like this you can pull but not push, and this was the idea of the push to make it work. It didn't work, so I took it off and now I use my shaper without. We take this little moment because it's sticker time. I received stickers from DJ from the United States, and I hope I'm gonna pronounce it right. Foxberg's Fabbercobblin or something. If that's not correct, DJ, I'm really sorry, but I did what I could. Right, as you can see, your sticker is already on the cheap door, so I'm sure it's nice and straight and you don't watch my back gluing it on. For the moment, DJ has almost 600 subscribers, and I think if I watch his channel, he deserves way more. He's the type of guy who isn't afraid at all to make his hands dirty, and he likes to play with his beautiful big machines making big ships. Go and have a look. Okay, let's continue. I'll bring the tool down. For the moment the machine is set at 60 strokes a minute. It gives me a cutting speed of 20 meters a minute, which is perfect. Oop, too tight. It could be that I need some support here below to prevent this part from bending down, but we'll see. Half millimeter cut. Here in the corner, it's not completely cleaned up, but I think I'm gonna leave it as is. But what I will do, I'm gonna do a spring pass in the other direction, and it will leave a better finish. Because it started to chatter a bit, here you can see a little bit chatter marks. I installed not a machinist jack because I don't have one, but a piece of pipe and a shim that just barely touched the underside of this thing, and you can clearly see the difference. These two faces are now finished, and what I would like to do is to clean up these two faces here, this one and of course the other side, because it's absolutely not square. Now, it's not really important that it is square, but I would like to have it a little bit okay. Now, there is a little problem. Normally you should put the part this way on the table, put it square here, and then work this surface in one go with the automatic down feed. This machine doesn't have any automatic down feed, and I'm too lazy to do this by hand. So I would like to do this way, so I can use the automatic side feed. But of course, the table is completely down. I can't go lower than this. And here is the problem. The RAM is too low. I don't have enough free space here. What I think I'm gonna do is to use these mounting holes here and install my part over here. And then I can cut this surface and after turn it around and do the other side. But because of this radius here inside, I can't put it straight on the table. So I'm gonna push it this way against this surface, and here between I will put a thickness. My multi-function things here, I think that will do. something like this and then clamp it down. That will work. Install this one here. So after, when the part is in place, like this, I can clamp on it. That's a bit the idea. This is the finishing pass, and as a finishing pass I always do a spring pass, so there's dials in, nothing at all, and I come back in the other direction. That's why you see the feed mechanism feeding on the cutting stroke. Normally it is wrong, but with these very small cuts it doesn't matter. Both surfaces are now finished, and I forgot to mention that I use the extended tool holder because the table is completely that way, can't go further, and if I put my cutting tool directly in this tool holder, of course it doesn't work. That's why I extended it a bit. For some people it's of course obvious, but not everyone is maybe familiar with shapers. Some viewers of these videos never touched a shaper in their life, and there's nothing wrong in that. That's why I explain. Of course, if you're a specialist, yeah, I suppose you know. It's time to make the surface that will take the gear or the pulley or the whatever that needs to be slotted. Of course, this worked surface is on this side. Here will be mounted the part, and the whole zwik will be installed this way on the table, the part on this side. So to cut this surface, I will install my part this way in the shaper, against the plate, against the stop here. And when I install the clamps, I have to be very careful that if the surface is completely finished, that the clamps will not touch the dovetail. I move the part to the end of where it must be cut. So if now I install my made in Germany clamps, I have to be very careful. This one will do, no problem. Looks good. This could be noisy, but we'll see if it works. Right, let's have a look under beneath this mud here, see what surface finish we have. It's a big mess. That's good. I drilled the holes and the whole thing is in place. and there's just enough wiggling to adjust it, so that's perfect. And first I thought use this thing, cut it in half and use it this way for more rigidity, but this thing, there's a bend in it, so I'm not gonna use this one. I prepared these two, cut off at 200 millimeters, which is the maximum work length for my little shaper here, and I think I'm gonna mount it this way somewhere. But before I do that, first I have to clean up at least one face to have it nice and flush with this angle. If you're wondering why there are 3 studs here instead of 2, because I made this yesterday, and I think yesterday was not a good day to work in the workshop, because I made a big hole here, and my idea was to use these screws here and then with a T-nut bolt them directly on the table. But I made some mistake and the bolts doesn't stick out enough here to go in the T-slots. I don't know what happened. I suppose I made a measuring mistake. So it happens, and I made a new one, and I'm gonna use the vise. Now, a small problem here, it's not a big deal, is if I clamp them together, there is some movement, which means 2 surfaces doesn't match very well. There's a very simple solution to this. We take some belt sander, sandpaper things, put it in between, like this. I take other bent sand belt things like this to protect my little vise here. Of course, with the sandy side against the workpiece and not against the jaws. And now that I'm talking mistakes, why not continue? Last week I watched a video made in a school, and the students, they were working on this magnificent big shaper, you know, at slow speed. What I can understand, because when you're learning something, take your time to do it right. So, perfect. One little detail, the shaper was running backwards. Now, normally I have absolutely no problem with people making mistakes. You see sometimes videos in the style, hey look mom, I have a new machine, and you see this guy is doing it wrong. I don't have a problem with that, because one day someone will put in the comments that, hey, you made a little mistake here, and then he learned something. Someone else will read this comment, he will learn something too. It's a double win, yeah? We learn with making mistakes. But a shaper running backwards in a school where we're supposed to learn the students how to do things, to do it the right way and not my way here with made in Germany clamps and pieces of scrap to hold it. No, the right way to do things. That's what school is for. So, in school, no. Even if you're not familiar with shapers, which is of course not a problem at all, but you can really easily see if it runs the right way or not. This shaft here is part of the main shaft that goes through, that runs the ball gear inside. And of course the ball gear has to run this way to push the ram this way on the cutting stroke. So you see this axle spin in the right way. Yeah? Have a look at some shaper videos and quickly you will find out that there's a lot where you see this axle spin the wrong way. Now don't look at this. This is the feed mechanism and it's a double system spinning the other way. It's made on purpose so you can take out this gear, reposition it and put it back in, and it changes the timing of the feed mechanism. That's all. That's why it's a double system. Now of course it's important to point out that if a machine, whatever machine, is running backwards, it's not the student's fault, of course. It's a school, the teacher, I don't know. It's absolutely not the students. Right, let's clean up these surfaces and make something. After a bit drilling and tapping and assembling, this is where we are now. So all that's left to do is make an opening here where my tool holder slotting thing can come through to avoid crash, of course. Now there's several ideas. You can make just a round hole, the lowest possible to gain rigidity, the highest possible so you can make bigger parts on it. That's a little bit complicated, I think, at the same time. I could make some kind of oval idea thing, even open the top, make it a V. I don't know yet, but I think the best way for me is just making a boring opening where my tool can come through, and that's it. The best way to cut this slot or opening in this part is to install it like this in a milling machine, which of course I don't have. But I think the best way, if you don't have the right machine for the job, use violence. Didn't work. I think I've been scammed. I found another solution. If I install my part here on the lathe, on the cross slide, of course to do this I use existing holes. They were already in this cross slide. So for the making of this video, no machines have been harmed yet. I never did that before, boring on the lathe like this. Right now, to hold, for example, this part in place, or this part in place, I would like to make a dedicated holder. So I found here some pieces of scrap. If I bore here the same hole like this one, of course cut this ugly thing off, and then weld two pieces on, like this for example. That could work. Now, if you think it looks a little bit stupid, I think you're absolutely right. It indeed looks stupid. Let's mount it on the shaper and see if it works. Here we go. I managed to make a key slot here without any casualties, so I suppose it's a success. Now this of course one little downside I didn't think about. When the part is in place and squeezed between these two plates, it's almost impossible to take measurements. So in this case it's even more important to trust the dials. But it works.